Now that all our data requirements are met, now we will get into the training process. Now training is a single command, and then we'll go into details into each of this. It has got different parameters and different moving parts. So I'm executing this in the Jupyter notebook, and that's why you have this symbol as you know. You can alternatively, you can also execute this in your command prompt, like here, the same thing. Only difference is you don't have to have these simple here. So now let's look at each of those parameters in this. Python obviously is to run the script. Now train.py, that's a script which comes along with the folder, or along with the YOLO file. So when we download it, you get this train.py folder. So it's a pretty large file. You can go through it to understand it more, but this has got all these processes to control the whole training process. So it looks at each of these different files and different parameters which we have, and then picks up the necessary components, and then ties together the whole training process. So it's available here in the root folder under YOLO v5 itself, the train.py. The next is the image size, which we give as you can give whichever image size which you want. So I've represented it as 640. Next is the configuration file. So this is another YAML file which comes with the folder, or with the whole package. Now you have something called so what we have represented is YOLO v5 m.yaml. Now M stands for the medium implementation of this YOLO file. So there are three different types of implementation. I'll show you this specific YOLO this file which is there. So it is under the models, and you will find all these things under the models folder. So you have this YOLO 5M. So M stands for the medium YOLO, L stands for the large, and the S stands for the small ones. These are some of the important ones. So we are using this medium YOLO file. You can also alternatively use the large or the small, anything which you want. So that's something which we have using here. Now if only difference is if you are using the large YOLO file, the YAML file, then alternatively you'll have to select the other hyperparameters also as large, which will come next. So next parameter is the hyperparameters which we give, and so here we give the path to the hyperparameters. So let's look at that specific folder. So this is the hyperparameters exist in the data folder under this folder. So here you will see the high, low, and medium one. So we have selected the medium one. So these are all those hyperparameters which are required to run this. Let's also look at the other YAML file, YOLO 5M. So here it represents the architecture. The YOLO v5m YAML file, it represents the architecture of the complete architecture of YOLO v5 of the medium YOLO file, and the hypes represents the hyperparameters which are required. So everything like your momentum, weight decay, etc. So there's a whole list of hyperparameters which are required to run this model. That's what we have here. So the next one is the epochs, number of epochs which we want. No, before that the batch number of the batch sizes. I've given a small number of batch sizes because the number of images which I have are very small, just 20 or 25 odd. Now depending on the number of images which you have, you can alter the batch sizes. So, and the next is obviously the epochs which you can define. You can change the number of epochs which you want. The next one is the data, or which gives you the YAML file which we created. So it is here under the data which we have created, that YAML file. So we just give the path YAML file here. So that's so it obviously we know that it is under data, and then we just give the name of the YAML file which we have represented. So the next one is the weights. So this is the pre-trained weights of the YOLO file. Now you will not find these files. So the weights are contained in this file called YOLO v5m.pt. You will not find this weight when you initially download this, so it remains in this. You can find this under this this folder YOLO v5, but when you download it, you will not find that there. But once the training process starts, once the training process initiates, it will look at whether this YOLO file, this file is there, the weights file is there. If it is not there, it downloads that. Now you can see that I have the YOLO v5m.pt file there, because I have done a couple of training with this, but you might not find that file here. But once you run the once you run the training script, then the YOLO file or the weight file will get downloaded. So this is the pre-trained weights which gets downloaded from the GitHub repository. And this is the number of workers, which is the number of cores which you want to use. And the last one is the name which you give for each of your implementation. So this is where you can you can represent your each run with a specific name. So I've given a YOLO pothole detection M3. Why M3 is because it's a medium run, and this was my third attempt. So you will find these these names under, once the training starts, you will find these under the under a folder called runs. Under that you will find it under train, and see, this is that specific name which is represented. So I have these many runs which are already there. So so you can now you can just implement this. You can just enter this, and then you'll find a lot of these messages which comes in. So you will also find, for the first time, you will also find that it is downloading the weights. So it'll go on for some time, because this is almost 500 epochs, right? And it'll look at so there is this early stopping also which is involved in it. And so if it finds that there is no more improvement, then it will stop early. So that so here you can see in my implementation, it stopped after 121 epochs out of the 500, because it didn't find any more improvement in this. So these types of improvements comes after based on the number of images which you select and the quality of those images, etc. And that's the basis of which you will find those improvements. So that's the whole training process. So once you run this, it will take some time, and then finally you will find all those specific files, or the weight files, updated weight files, which are required to this. So now that's all about the training process. Next we will get into the inference process, and again it is the inference process is again through a specific file which is already which will be there, called the detect. So we'll see the inference process next.